Malik, you on? Malik, can you hear me? Donald, can you hear me?
Yes.
Okay. Hey Malik, we can hear you singing, dude. You might want to put it on mute. If you want us to hear you singing, I'll just have to get louder.
Oh, get one.
No rest. Okay. Good weekend. You don't get rested, right?
God damn.
Sam, stay out of trouble? Some. Got a little bit of trouble? Did you get caught? Good. That's the best type, bro. I ain't even asking. You don't want to know what you did this week. Pursue innocent. Where's Howard? Howard, you okay? You awake? Okay, Spencer. You think these masks keep me? I can still see your eyes. And, teaching high school like I did for 6 years, always had to learn to look at people in the eye, and that way you can tell if they're getting a little mischievous. Let's see, who needs to mute? Somebody needs to mute. All right. Okay. I think it's time. We'll go ahead and get started. Test. Issues with the test. Everybody got it turned in? Any issues turning in the test? Okay. Yes.
No, sir.
Oh, you're supposed to turn it into me? Okay, what you need to do is scan it and get it in as soon as class is over, okay? Okay, get it in. Get it in on there. I put on Canvas, there's under assignments, it says a place that says, what's it say, turn in test here or something? Yeah. Either take pictures and you can put those into a Google Doc and make that into a PDF, or yeah, scan it that way. I mean, just try to get it to a PDF document, because what happens is, one, PDFs have less size, and if you've got an Apple phone and you send me an image and I'm running a PC, or I'm sitting there on my phone or something, I got an Android tablet there, it's going to cause me issues. I'm grading with that, so that's why I asked for PDF format. And I think about everything, you can create PDFs about anything now, correct? Is that correct? Your computer's something. What's the easiest thing to create PDFs with? Google Docs?
Word document.
Word document, just pull up Word. What else? Anything else? Stick it to a Word document?
Yeah, Word documents. You can do it on Google Drive too.
Or if you try to like print something, you know, have an option to
save it. Sometimes save it as a PDF or something like that. Okay. All right. So was the test, I hate to say this, was the test too easy?
No, it's so hard.
You lie. Was the test too hard? Or you don't have anything to go over, I guess. My real question is, did the test go over anything I didn't include in class? Did it go anything that wasn't covered in the book or in the homework? So as it did that, was it a fair test in that regard? Okay. Now this one tends to be a little bit simpler since it's the first one. Next one will be more difficult. It's on projectile motion and vectors, two-dimensional motion. People can think in a straight line, but diagonals and curving tends to give problems a little bit. And analysis of it is more difficult, okay? So that's what we're gonna work on today. We're gonna start on that. Lab today will be on projectile motion. We're gonna do video analysis. I'm gonna try to get some labs back to you today. If I can, I've got some time available. I'll try to get last week's lab. Everybody got last week's lab turned in, right? Okay. We'll try to get that back to give you some, so you give you some feedback on that as best I can. Let's see what else. Homework turned in. Did you turn in homework via the site? Any issues?
Just a live PDF.
What's that?
Just a live PDF.
Yep, that's okay. It's okay. Did you do the homework while you were doing the test? Some of you, Prashil?
Yes.
Yes. Thank you. Thank you for being honest, Malik. Was that you, Malik?
Yes, sir.
Okay, thank you. Is that recommended, Malik, to do that?
Sure.
Not really.
Sir.
Malik had 212 first, and then he's taking 211. I'm not going to fuss at him too much because he knows the deal.
I did the first part and I got behind.
Gotcha.
Yeah, so I had to catch up.
And ketchup's a lot harder than mustard, right?
Yes, sir.
All right. See, it's these jokes in the morning. That's what keep you awake, right, Sam? Did you get that joke? Do I need to explain it? I'll explain it later. But try not to get behind. I would recommend that extremely. Now, Michelle, what did you say when I first came in? About the homework?
Oh, the homework is easier than, sorry, the homework is harder than this.
That's kind of the idea. If I made the homework harder, the test harder than the homework, did the homework prepare you for the test? No. Could I make the homework at least one problem on the homework equal to the hardest problem on, one problem on the test equal to the hardest problem in homework? Would that be reasonable? Maybe one little sub-bullet like 3C. But if I made it harder, yeah, I need to do that. If I made it harder, that wouldn't be right in my opinion. I wouldn't be testing correctly. Now, I'll try to get back to you. Probably takes a week, week and a half. I grade out 105. So if you sign your name, Hunter, you made a 5 on that test. Now, is that really good? 5 sucks. That's bad, right? But I do grade out 105. Why? Because I count off on units, because I count off on sig figs. Everybody's going to make a little bit of issues sometimes, have some issues with things. So if you make 100, does that mean it was a perfect test? No, but you were darn close. And in this business, darn close is really, really good. Okay, seriously. There's always error in everything you do, and you'll see that as you do the test, do the labs especially. Any comments, questions, concerns, test, homework, way things are going to be run? Editorial comments, Prashil? Okay. Yeah, as expected, I guess. Was the test as expected, Micah? You pretty much, I told you what would pretty much be on there, and was it pretty much on there? Okay. I can't do much better than that, I don't think. Jordan, any issues? Okay. All right, well, let's get on the road, right? Let's get going. All right, let's get going. So I was working on vector math. So Prashil, what was the last thing in my notes on vector math? It's the last thing I put up on the board. You didn't have your notes ready out front when you
Not last week?
You should have been reviewing your notes from the previous week as you walk into class or before class, so you'll be ready for what I'm going over this class, right?
Sure.
Right?
Yes.
Thank you, Prashil. It'll be done next time, correct?
Yes.
Good job. As we all wait for Prashil to find his notes from the last time. Keep going.
Probably not a good idea.
So did you actually take notes last time?
I did.
Did you look over them before you came to class?
That's gonna be.
Well, at least you're honest. You know, that's like plus a few points, but minus many, many points for not doing it. Well, Prashil finds it, who have I called today? Atkins, where's Hunter Atkins? Atkins, what's the last thing I went over?
Unit vectors.
Unit vector. So I explained what a unit vector was. That's pretty much it.
You're talking about the
I-hats and J-hats and stuff like that. What? All right, Paulus, what's an I-hat?
Isn't it just one? Right?
It has a value of 1. And what direction is it in? Is I-hat a vector, first of all?
The I is in a positive x-ray.
Right. So unit vector, it's a vector. Unit means magnitude 1 in the x direction. J hat. It's a unit vector in the y direction. Positive y, I should say. I will argue you have used unit vectors in your life when you talk about things. You just didn't realize it. Ah, Paulus, that perked you up a little bit. Let's see, what could that be? So, let's see. Connor,
Yes.
you drive?
Yeah.
Where are you from originally?
Charlotte.
Charlotte, that's right. I remember that. My apologies. It's going to take you a little time. So, Connor, when you drove from Charlotte, did you drive up this way? No, did you fly?
Oh, I drove this.
Okay, so somebody drove, right? How many miles is it?
Um, 15,
Maybe 50 miles? Let's say 50 miles. 56, say 60 miles. So 60 is the total number of miles. What is the unit of measurement you use to get up here? Not miles per hour. For unit measure of distance, I'm sorry.
so.
Miles. So your unit measurement was miles. Now, the direction you went was here. So you could say you went positive, right? So really, with traveling 60 miles, you dealt with a unit, but not a unit vector, right? So there's the unit magnitude of 1, because a mile is 1 mile, right? Let's think of vectors then. So let's think of this in terms of a business. And Prashil, since you've been in here, I'm just picking on you a little bit today. Now, you went out and decided to make some money one weekend. So you actually worked and did a job, a job that doesn't involve, this all day long. And you came in and said, Dr. Knight, I made $30 this weekend. For me, that's a lot of money. And I would say, what is your unit vector? And you look at me like, what the heck are you talking about? Right? Well, if you made money this weekend, first of all, what is your unit of making money?
Dollars.
Dollars. And did you make money? So is that profit or loss? Profit. So making money would be positive, loss would be negative. We're losing money. So 30 is the magnitude of how much you earned. The scalar for that unit vector. $30 profit is your 30 times your unit vector, dollars profit. This isn't just a concept that we throw up in physics and we make you learn it and it seems useless. Right, Sam? Not that you're thinking that, right? No, not a bit. Not a bit. unit vector, that's what you're measuring it in, and it's direction. Unit in a direction, all right? We're just writing this out formally so our math works, okay? So if I want to write a vector, and here's some a vector here, I can break that vector down into x and y components. They can see that. All right. So I break it down in x and y components. I would get this much in x, that much in y. So this would be a sub y, a sub x. But I could write my a vector as a sub x I hat plus a sub y j hat. That's how I can write my vector. So this is a mathematical way of writing vectors, doing math that works. Now, I mean, that makes sense, but let's do some vector math with this, because that's why I said we did this. All right, let's find some a vector, and we're going to add to it some b vector. Let's add together these two vectors. Now we could use the head to tail method, right? We could do that. So if we do that, we get this is a vector, that's b vector. So this then would be our c vector, and we would say c vector equals a vector plus b vector. And of course, A, B, and C are it could be whatever vectors, right? It could be position, it could be displacement, it could be velocity, acceleration. Later on, we'll learn about forces, fields, momentum, whatever. All right. But can you do head to tail mathematically very well, Emerald? Can you do that in a calculator? No, you can't. You can't do that very well in a calculator. If we can't do it in a calculator, Sheil, it can't be done, right? So you got to give the little God information and let it tell you the right answer. That's all it ever does. Well, what if we looked at a vector as a sub x I hat plus a sub y j hat, and then look at b vector as b sub x I hat plus b sub y j hat. Because if it's a b vector, it's got a little bit in x and a little bit in y. Now that y is going down there. Howard, you notice it's down? But so this b sub y, it would be a negative number, but do we put a negative in there? Do we need to? We're just saying that b sub y is just a constant of something. Positive or negative. Same for b sub x. Okay. Well, geez. If we're doing addition here, why can't we just add these there? Because if you go in the I hat direction, do you affect j at all? Do you? You go across, do you affect up and down, Jordan? If you go up and down, do you affect the cross? I'm going to do the floss. I'm sorry, that would be cringy, right? Sorry, Caleb. That was really bad. Sheil, can you do the floss?
I'm not going to floss.
But what can I do with it? Since they're independent, could we just add up the ones that are in one direction, add up ones in the other direction? They're independent. So I'll just add up all the I hats and add up all the j hats. And if I do that, can I do that? Are the math Is Dr. Goldberg gonna come over here and wrap me on the hand with a plastic ruler? He might do that anyway, but that's another story, right, for sure.
The camera a little high.
That point,
The camera a little high.
oh, there you are. You got feedback. Okay. All right. Questions? Paulus, does this make sense? Sort of, kind of. Well, why don't we do an example to see if it makes sense? How's that sound? Let's take an example. This is going to be very similar to the one in the book. Let's say A vector is like this. And we're going to say that B vector is like that. All right. Now, normally, using a head to tail method, we would do like this plus that. That would be our C vector. And this works on displacement, right? This works on displacement. So, anyone over 21? 21 or over? You over? You're not. Prashil? All right, Prashil. It's you today, isn't it? Today's, use Prashil as the example day. So Prashil decides to go out with the guys and drinks adult refreshments. He can't walk too good. So the officer asks you to do a walking test. You know, can you walk the line? Johnny Cash walk the line? All right. So the line is supposed to go from here to here. But Prashil kind of stumbles this way a little bit and stumbles back the other place. And he kind of falls down right here. So Prashil, you're getting the ticket, right? You're going to see the magistrate. All right, that's not a good night, is it? So we don't recommend that, do we? No. Now, so this makes sense that you could have just walked straight here to here. So from a displacement point of view, you walk this way, then walk that way. This makes sense addition-wise. Tip to tail makes sense? Doesn't make sense. Okay. So Prashil, you start here, right? The officer says, walk over there to that tree. Well, here's the tree. Okay? So as you walk to the tree, you walk over here. And then what do? And then you kind of lean like that when you're walking. And now you're at the tree. You hit the tree. But did you go straight to the tree?
No.
No, you went this way for a little bit, and that way a little bit more, right? Is that what I drew right here for displacement? Displacement meaning distance in a certain direction. So I could have just went straight here. Or you could have went straight here, but you decided to take the scenic route, right? All right. So that's how we add things up. Because either one of these, so we could say then that C vector equals A vector plus B vector. We could say they're the same. Could you get, so are these really, so we add these two up, is that going to be equal to C vector? Would that be equal to this displacement? From a beginning to end point, right? Beginning to end point it is.
Because you got to the same place.
Just different ways. Just different ways. All right. So let's look at this. And I'm going to say this A vector is equal to, we'll say A sub x, and we're going to call that 5 meters I hat plus 5.0 meters I hat plus 3.5 meters J hat. And B vector, our coordinate system is going to be This is the X direction, and that's the Y direction. You went over just a little bit, so we'll say that 2.0 meters I hat minus, we'll say that 6.0 meters J hat. So let's add them up. And if I use this, so add up the components, add up all the X components, add up all the Y components, Howard. That's all I'm really saying, right? This is just add up all the X components, add up all the Y components. So 5 plus 2, 7.0 meters, plus 3.5. I'm going to do this just so you can put it in your notes. Now, combine them. 5 and 2 is 7.0 meters I hat minus 2.5 meters J hat. And let's see if that makes sense, Paulus. And if you look at it, well, if here to here is 5, we're saying that right there is 7.0 meters. We're saying down this way is minus 2.5 meters. Does that seem reasonable? All right, that's reasonable. What's the magnitude of C vector? Anybody, tell me how to find the magnitude of C vector. Magnitude of C vector. Let's see who knows how to do this. What's that? But what do you got to do to each component here and here? What do you got to do to them? Could use a really old joke and say you got a Huey Lewis them, right? Because the old band Huey Lewis and the News had the awesomest song from the 80s, Hip to Be Square. Ah, you got to square them. Remember, is this Pythagorean theorem? There we go. If you want to know this, square this one, square that one. So we're going to CX squared plus CY squared. And we're going to square root them. So that's 7.0 meters I hat squared, or the component, it's the component there, plus negative 2.5 meters quantity squared. We'll take the square root of that. That's 49. 2.5 times 2.5 is 6.25. Negative times negative is a positive. So, Mr. Phelps, that's 55.25 if I did it right in my head. What's the square root of 55.25? Square root of 49 is 7. Square root of 64 is 8. So I'm thinking that's what, about 7.3? Somebody do it on their handy dandy little God calculator.
7.43.
7. Dang it, I'm off. Stop that. Michelle, I gotta get better, man.
You do, I agree with you.
So we gotta do 2 sig figs, 7.4 meters. Now, this is a vector. Vectors have 2 attributes. What are those 2 attributes? Keelan, what are the 2 attributes of a vector? Vectors have blank and blank. Uh-oh. Go back to your notes. You ever find your notes, Rochelle? So you didn't take notes?
So I have to take the,
Hmm?
it's just from different notebook and not this notebook.
Were we prepared for class?
Yes.
What's it? Somebody said that. What's that? Excellent, Keelan. That's exactly right. Notes make a difference, right? Notes you can find, right, Keelan? Notes that you can read and use in class. All right. So how would we find direction of this vector? What trig function, Paulus, can relate c sub x and c sub y to that angle theta, Paulus? Tangent. Exactly right. So we're going to say the tangent of theta equals cx over cy. Now you're right, we would do inverse tangent. You know why I write it like this? Because in my mind, do I want to remember a formula for theta, or do I just want to remember the tangent formula and use algebra? Exactly. Because algebra we should know. We should know. So if I write this, I go, oh, okay, now I just get theta by itself. Theta is the inverse tangent of cx over cy. Just so these guys can see it. So cx is 7.0 meters. This is negative 2.5 meters. Inverse tangent of 7 meters over negative 2.5 meters. Make sure in degree mode. And my gut, 20 degrees. It'll be negative 20 degrees because we're going down into the fourth quadrant there. But I'm saying about 20. Somebody do that for me. Emerald, you got it? Okay, you get your calculator. Keelan, you got your calculator out? Yeah, there you go. Why would I make you do this in class? We would never do this on the next test. Right, Connor? Multiple thumbs up on that. So what is it, somebody? What you got, Paulus?
I got negative 1.2.
Dang that radian mode.
Yeah, that's right. Yeah.
Oh, we didn't give our little God the right offering. You got to placate the little gods, or they will give you crap information back.
And I got negative 70.
70. Ah, 70. Come on. Gosh, I'm waiting for somebody to see this. Go ahead, Paulus.
Yeah, you mixed up the CY and the.
Thank you. This is why we do the work. Because, Paulus, do you remember the last thing I said to do when we were solving problems? What do you do with your answer? Do you take your answer and write it down and go, oh? You check it for reasonableness, right? And can this angle, because the way we drew it, and I didn't draw it to scale, but I'm close, can that be 70 degrees? No. So the little calculator God is wrong, or I did something wrong. Since you know the calculator God is never wrong, what should you assume first? Seriously, all kidding aside, the calculator only works with what you give it, right? So let's see if we did something wrong. And when I put cx over cy, I want to see if anybody would catch that. Rocio, did you catch that? Or did you just assume everything I said is correct? Because what is tangent by definition, Rocio? Rocio, what is tangent by definition? Oh, that's not good. Opposite over adjacent. We could have, but we talked about that last class because, and I think you had to watch the video for the last class. The reason we don't is we already calculated the information, but you could have, but you're taking a chance of getting it wrong. This is really opposite is cy. Adjacent is cx. Yes, sir, Keelan. You just stretch it. I understand that. Cy over Polish, you got me there. Something was
I
funny,
was
right?
gonna say something, I was like, something that doesn't look right. And then-
I'll tell you something here in just a minute. Okay, now, what does that give us? About 20 degrees? Negative 20 degrees. Now, I got that one right. I can do my tangents in my head. Is that correct, the 2 sig figs? Okay. So did we find the magnitude and the direction of the vector that sums together from A and B? And does this say then that Priscilla, in his drunken stupor, how far did he walk from beginning point to end point? From here to here, you walk 7.4 meters. Now, if you want to take path, that's a lot longer. And in what direction was that tree? Negative 20 degrees from the x-axis, if we say that like straight in front. Fair enough. Is this how we add vectors correctly? God, I gotta get you woke up, Micah. You knew this, though, Micah, but you were a little sleepy, right? All that training you did this weekend?
Sure.
That's it. I came up with a good answer. That's all that training. Okay. Questions? This is a good one. It's a lot of stuff. But yes, sir. Go ahead, Sam.
Is there a way to like find it if the second vector like isn't at a right angle with the x-axis?
Very good question. Is this actually at a right angle with the x-axis? It's not. If you look, Sam, example 3.6 is that way as well. In the book, I basically took 3.6 and just changed the values a little bit. When you add up components, will they always be perpendicular to each other, Sam? Let's look at these components. What direction is I have? Positive what? X. What direction is J have? In this case, negative. But one's always in X, and one's always in Y, right? Our X and Y coordinate systems, the way we use them, always perpendicular to each other. Yes. I don't get into the mathematics, Sam. They may not be. There's ways of doing or what's called non-orthogonal coordinate systems. That's grad level, and I don't want to do them here. And I've had to do that, and it's pain in the boo-hang. How's that? You got to use linear algebra like crazy, and 3 by 3, just huge matrices and stuff. So, but from our perspective, because we're walking, right? X and Y will always be perpendicular to each other. And if they are, if you find the X components and the Y components, can you always use Pythagorean theorem and inverse tangent? And the answer is yes. How do I tend to add vectors? Now that I've shown you 3, 4 different ways of doing it. That. Does it work every time? It's a little bit extra math. But if you add vectors by adding up their components, it makes life easier. And what we're going to show, and I'm getting ready to show you here in just a minute, is in chapter 4, when you solve 2-dimensional problems, it's best to break them up into 2 one-dimensional problems. You don't want to be solving both of those at the same time unless you absolutely have to. All right? That's a pain. That's a pain. Any other questions? Thank you, Jordan, for showing that. Sam, does that answer yours? Any other questions? Malik, you good? Okay, who else is on here? Prather, Lou, you good?
Yes, sir.
All right. If you're good, let's go to chapter 4, motion in kinematics in 2 dimensions. Kinematics in 2 dimensions. We've been doing kinematics in one dimension. Guys, should I call on somebody besides Bashil? You can just keep calling on Bashil today. Keep calling on Bashil. Is that good, Jordan? Okay, Bashil, what's kinematics mean? Bashil, do you know the term kinesis?
Yes, I've heard of it.
You know the term kinesiology?
I've heard that too.
What does it mean? So you know words but don't know what they mean.
I've heard of them, and it's been years.
Yeah, it's in years. So your vocabulary is filled with words you don't know what they mean.
Maybe.
Okay, yeah, you're a computer science guy. I'm picking. Kinesiology. What does kinesiology mean? Anybody then? Who said that? Motion, kinesis, from the Latin. And if you study kinesiology, what are you studying actually? Motion of the human body. So if you're doing exercise science, a lot of the athletes end up doing exercise science. It's not a bad thing. If they want to make their life around sports, either by training, being a trainer, by doing physical therapy later on, actually just selling equipment in that. I'd get a business minor as well with it, or somehow maybe do a little bit of both. But kinesiology is something we have an exercise science doctor. I am blanking on his name. I have a good friend over there that I can't remember what's his name at the moment. He's really good in that field. Huh? Keith Lighting, yeah. Keith Lighting. Yeah. Lighting's good. Lighting knows his stuff. We've worked on some projects together, actually. And we're hopefully going to work on another one this year with Derek and Quentin, working on something for the football team, a project. Now, when we do kinematics or motion in 2 dimensions, so 4.1, motion in 2 dimensions. Before we had basically, even though we were going down a ramp, it was still going straight down the ramp. And we tilted our coordinate system, so our coordinate system went down that ramp. We were just going in X. We're just going in Y. For the problems we did for stuff going up and down, we'd take something and we'd toss it up in the air and then drop it or toss it and let it hit the ground, right? Stuff like that. It was still in one direction only. Now things are going to move in 2 directions. Motion in X and Y at the same time. Now the book does a very good traditional explanation of explaining motion in 2 dimensions at the same time. They're very rigorous and they do a very good job at it. They do it with velocity vectors. I'll just say, and it works. I have taught this before, and the students go through, they do everything I ask, and then they really don't, I didn't know what they were doing when they got done. So, how can I sum up page 81 in your book? The best way I can sum it up is say motion. I'm going to define that as displacement, velocity, or acceleration can be broken down into X and Y motion separately. and solved in that manner. This is going to be the key. I have to summarize all of this. All right. Why can you do that? What is velocity? What did we talk about in chapter 3? What is chapter 3 about? Vectors. Huh. Is velocity a vector? Is acceleration a vector? Is displacement a vector? Can you break a vector down into its x and y components? We just did. So we can break displacement down into a vector, which is what you did. You didn't do that. We're just using that as an example because you would never do stuff like that, especially writing for stuff. But even then, just your normal attributes would never be that way. Could we get the velocity of a car into x and y components? Could we get the velocity of an athlete running? Could we get the acceleration of a ball in the windup of a pitch? Could we get the acceleration of something spinning around and around? Could we use, anytime we deal with acceleration, what is acceleration, Hunter? Excellent. And what are the 3 accelerators you have on your car, Jordan? Name me one of them. Name me another one, this Hunter. Give me another one. Gas pedal. As long as you go faster, go slower, or change direction, you are accelerating, right? Gravity is in an orthogonal direction to most cars driving, assuming we're driving on a plane. So gravity, we're going to assume in a horizontal motion doesn't accelerate. Okay? What on the car does acceleration? That would be an attribute to the car itself in a gravity field. I don't want to talk about that yet. Now, if we can change the motion of a car by going faster, by going slower, by changing its direction, we can then, and we know we can break vectors down into components. Can we break velocity acceleration down into individual x and y motion? And the answer, of course, is yes. What we're going to want to do is, because these are vectors, break each down into x and y components first, and then solve the problem in x and y separately. We want to solve it in x and y separately. And honestly, that is the gist of everything they do in the section 4 up to section 4.2. And because of our lab today, I do want to talk about projectile motion for just a minute first. Okay. First of all, let's look, my apologies if you wanted math in this first section, but honestly, that's what they're trying to get across, as best I can tell, okay? Read section 4.1. That's the big idea, though. Projectile motion. Projectile motion. So what's a projectile? It's an object moving, and this is key, in 2 dimensions, only influenced by gravity. Only influenced by gravity. Gravity is the only thing that's changing its motion. Cannon. Cannonball. What are some examples of projectiles? Cannonballs. Give me some other examples. What's an example of projectile in lacrosse, Paulus?
Lacrosse ball.
Lacrosse ball, we'll say balls thrown / slung. Or you sling them in lacrosse, I guess. Is that the correct term? Pitch.
We used to say throw.
Throw, okay. I'll say slung. Pitched. Etc. Oh my goodness, I'm sorry. Okay. Let's see. It could be cats sliding off counters. Tom and Jerry, right? You guys watch Tom and Jerry? You still watch Tom and Jerry even though it's old school? It's pretty cool. And the cat Tom's always running off the counter, flying in the air, and Jerry, of course, doesn't for some reason. I always wanted Jerry to get eaten. But I like cats. Let's see, cars off a cliff. Can we think of any other good projectile motion type problems? Basketball and hoop. Very good, Caleb. And that's actually very prescient. So that's what you're going to do today in lab. We're going to look at a basketball. Guys, we're shooting a basketball into the hoop or into something. We're shooting a basketball. And it's going to move. They're not throwing my phone. So it's going to go in projectile motion. There is video of that motion. Now let's think about, for projectiles, I'm going to leave it there. For projectile motion, what is the horizontal acceleration? What is accelerating it horizontally? Malik, any idea? What's that? Is anything pushing on it or making it move horizontally? If you shoot a basketball or throw a football, you do, but as soon as you release it, are you? Is anything? So does it have anything to make it go faster or slower horizontally? Assuming it's neglect air resistance. Is there anything? No.
Because like when you're accelerating, you constantly have to apply.
Not always. Something has to make it want to accelerate. I will say it. We haven't talked about what forces are yet, Caleb, and I don't want to get into that too much. But you are correct in that respect. Now the horizontal acceleration is 0. What's the vertical acceleration? Is anything trying to make it go faster down? Gravity, right? Gravity. So that's going to be equal to negative 9.80 meters per second squared. So with that video I give you, if those are the 2 criteria, one for horizontal one for vertical. You think I might make you do a graph of velocity versus time? No, I'd never do that, Connor, would I? Make you do a graph, velocity versus time, then if everything's done right, we'll have what as the slope? 0. When I make you do another velocity versus time graph, that should have a slope of negative 9.8. Is that going to be the gist of why we're going to do the projectile motion lab? Yes. Now notice, I have a horizontal part and a vertical part. Now Wednesday lecture, we're going to work projectile motion problems. But what I will do, let me move this so I will basically say this is X direction, this is Y direction, and I'll say the time in X equals the time in Y. So how do you solve projectile motion problems? You'd think only in X, which is horizontal, you think only in Y, which is vertical, but what do they share? Both show the time in flight. Because the time up in the air is the same for both X motion and Y motion. Right? Okay? What's that? It's for sure. All right. So, any questions? Any questions? That's all I got right now. I'll see some of you in lab. I'll see some of you in lab tomorrow. And Wednesday lecture is going to be a good one. So take good notes. Thank you very much for doing the test. Have a good day. I am a little early, but I can't really go any further. Jill?
Oh, no, I know that.
I'd like being seven.
That's my look.
Yeah, I'm okay. I'm okay.
Yes, sir.
Last time I saw you, you said I was going to say
Did you not get one?
Right down to here. I'll talk to Wellen about it. Okay. Hunter, what's your last name? Flynn? Yes. Okay, and this is over the group invite?
Oh, she said, the group meeting?
We have a group invite? and Canvas.
I the group meeting.
Okay, Canvas invite.
Oh,
Okay, that was my bad, then, since I have to do Canvas.
okay.
All right, thank you.
I only have a little.
Yeah.
You have a good one. You have a good one. Hope you guys learned a little bit.
Yes, sir.
Do good on test?
Yeah, we can go through it right now.
Good job. Okay, just get it sent in. All right, let me take this care of this mom.
Okay.
All right, can I call you back in a few minutes? I'll call you back in a few minutes, bye. All right, let me end this sucker.